Okay, so we have been, we started this chapter on stoichiometry, did a little bit of an introduction on Monday. Yesterday, I think you guys did mole to mole ratios, figuring out what's the ratio, how do you convert from moles of one substance to moles of another substance in a chemical reaction. And so we're going to, kind of take it a step further and talk a little bit about how do you convert moles of something to grams of a product. Okay, so we're going to be moving from moles to grams and then backwards from grams to moles. So today, that's our objective today, but let's just quickly recap mole to mole stoichiometry here. I have an example. In a spacecraft, the carbon dioxide exhaled by astronauts can be removed by its reaction with lithium hydroxide, according to the following chemical equation. How many moles of lithium hydroxide are required to react with 20 moles of carbon dioxide, the average amount exhaled by a person each day? So remember, our first step is just to make sure that this equation is balanced. I know in my mole to mole ratio, I kept forgetting to do that, so I'm trying to get that in my head. Hey, make sure this is balanced. I look at it, I got one carbon on one side, carbon on the other, 2 lithiums, we're good, 4 oxygens, yep, I see that, and 2 hydrogens. So this is balanced, so I can go ahead and proceed to the next step, which is start with what you're given. So we are given 20 moles of CO2, okay? Okay, so 20 moles of CO2, we are trying to get to lithium hydroxide. Okay, so LiOH. We want to know how much is needed to convert this substance into something else. So if I look at my chemical equation, I have a 1 in front of the CO2 and a 2 in front of the LiOH. Now I'm in CO2, so that's what goes on the bottom. CO2 needs to go on the bottom of your mole ratio. So you should have 1 mole of CO2 on the bottom and 2 moles of LiOH on top. Now, they're asking how many moles of lithium hydroxide is made. Well, it's moles, so my CO2, let me get my marker here. My moles of CO2 will cancel, okay? 20 times 2 divided by 1 should give me, I gotta switch back to a 40 moles of LiOH. So that's what mole to mole ratios, that's all that was about. But we're going to take this a step further. Okay, we're going to go from moles to grams. So instead of 1 conversion factor, we're going to need 2. A lot of times you're going to be given a substance in moles, and then they want to know what's the mass of the unknown substance. So your 2 conversions are going to be the mole ratio, because you're in moles. Moles of one substance, you got to get to moles of another substance. The only way you can do that is with the mole ratio. And then the second conversion is, well, geez, they want to know mass. So you have to figure out the molar mass of your unknown substance. So steps, start with the balance equation, figure out the mole ratio and molar mass, set it up like this, check your work. So in photosynthesis, plants use energy from the sun to produce glucose and oxygen from the reaction of CO2 and water. What mass in grams of glucose is produced when 3 moles of water reacts with carbon dioxide? Now, I'm being really mean here in this example because I'm not giving you an equation. You've got to figure this out. So the products here says produce glucose and oxygen. That's what's being produced. It's being produced from CO2 and water. So I actually got to write up my own chemical equation here. So CO2 and water are my reactants. So I'll just go ahead. CO2 and H2O. Now that with a little bit of sunlight gets us C6, H12O6, that's glucose, plus oxygen. Now if you write O, you're going to be in trouble. Okay? O it's never really ever by itself. It's going to be O2. Okay? Oxygen gas. Okay, now I got to make sure this is balanced. So I'm just going to change markers here. Oh, let's go green. Why not? Okay, so we're going to take some inventory, make sure this is balanced. So you might have to do this on some of your problems. So I got carbon at 1, oxygen at 3, hello, hydrogen at 2. I come over to the other side. Carbon's at 6, oxygen's at 8, hydrogen's at 12. Yeah, we are not balanced. So I'll start with my carbons, put a 6 here. Remember, you can only add coefficients, but this 6 distributes all the way through. So 6 times 1 is 6, 6 times 2 is 12, plus 1. Now I have 13 oxygens. My hydrogens, I got 12 on this side and 2 over here, so let's put a 6. Turn that into 12. 6 times 2 is 12, plus 6 times 1 is 6, so 12 plus 6, you get 18. I come back over here. If I put a 6 here, 6 times 2 is 12, plus 6, 18. All right, now we're balanced. Okay, step 1's done. Okay, step 2. We got to figure out what we're given and set up our mole ratio and then the molar mass of what we're trying to get to. So we start with 3 moles of water. Okay, so I'm going to put 3 moles of H2O. Now I got to figure out my mole ratio. I'm going from water to my unknown, and my unknown is they want to know glucose. So I look at my chemical equation, I find water, and notice there's a 6 here. I also find glucose. There's a 1 here. Okay, so I'm in water. When I set up my mole ratio, that means water has to go on the bottom. So it's going to be 6 moles to 1 mole of C6H12O6. So that's my mole ratio. The second conversion is they want to know how much glucose in grams is produced. So now I have to figure out the molar mass of glucose. Okay, so I'm going to change markers here. Oops. Let's go blue. So glucose. I have carbon. I got 6 of them at 12.01. Hydrogen at 12.1.01. And oxygen, I have 6 of them at approximately 15.99. So I add these all up, calculator, and I get 180.12 grams per mole. So that number, okay, is going to go over here because I'm in moles of C6H12O6, so that means 1 mole of that is going to go down here. And my molar mass goes on top. So now I'm just going to go 3 times 1 divided by 6 times 180, that's 180.12 divided by 1, and I should get my answer in grams of glucose. And I get approximately 90.06 grams of C6H12O6. Now, I'm not going to be picky on sig figs here. I should be, but I'm not because of this whole distance learning thing. So, yeah. This was my mole ratio. This was the molar mass. Notice that when I set this up, moles of water cancel. When I set this up here, moles of glucose is canceled. And the only thing left is grams of glucose. Okay? So let's try another example. And it's still using the same photosynthesis equation. So if I just go back and just look at that, 6 CO2 plus 6 H2O yields C6H12O, 6 plus 6 H2O, so 6 CO2 plus 6 H2O yields C6H12O6 plus 6 O2. So I already know this is balanced. So my second step is, figure out what you're given and set up your mole ratio and the molar mass of what you're trying to find. So I'm given 3 moles of H2O again. All right, cool. So that's what I'm given. This is my mole ratio. Okay. They want to know the mass of CO2. So here's water. Here's CO2. Looks to be a 6:6 ratio here. Now I'm in water, so water goes on the bottom. CO2 goes on top. For my second conversion, it's the molar mass of CO2. So molar mass of CO2, I have carbon 1 at 12.01 and oxygen 2 at 15.99. I add them up, punch it in my calculator, I get about 43.99 grams per mole. So when I set this up, I'm in moles of CO2. That means 1 mole of CO2 goes here, and the molar mass of CO2 goes on top. 43.99 grams. Okay, so now all you got to do is punch it in your calculator and get your answer. So moles of water will cancel. Moles of CO2 will cancel. I should be left with grams of CO2. I punch this in my calculator. 3 times 6 divided by 6 times 43.99 gives me about 131.97 grams. Somewhere around there. So that's going from moles to grams. So let's go backwards. Let's go from grams to moles. You're just basically going to flip the order of your conversions. So instead of doing the mole ratio first, now you're doing your molar mass first to get to moles, and then do your mole ratio to convert from mole of one substance to mole of a different substance. Okay, now in your notes, please make these corrections. I realized that I did not type it incorrectly for your active notes. Okay, so the first step in the industrial manufacture of nitric acid is the catalytic oxidation of ammonia, which is NH3, plus oxygen yields, there's that nitric acid, HNO3, plus water. The reaction is run using 824 grams of NH3 and excess oxygen. How many moles of HNO3 are formed? So first off, let's just make sure this is balanced. I got 1 nitrogen on each side. I have 3 hydrogens on each side, and I have 4 oxygens on each side. So this is balanced. Second step, start with what you're given. You're going to use your molar mass first to get to moles, and then the mole ratio for your second conversion. So I'm given 824 grams of NH3. So my first conversion is the molar mass. What's the molar mass of NH3? So I got nitrogen at 14.01. Hydrogen, I got 3 of them, each at 1.01. And when I add that up, punch it in my calculator, 17.04 grams per mole. All right, now I'm in grams, so that means grams has to go on the bottom. This goes on the bottom. 17.04 grams of NH3. I don't know if I said NH4, I meant to say NH3. That is equivalent to 1 mole of NH3. So if I were to measure out 17.04 grams of NH3, I would have a mole of NH3. So then my second conversion is the mole ratio. You look at the chemical equation for this one. There's a 1 here, and I'm trying to get to HNO3, which is here. Notice there's also a 1 there, so it's a 1-to-1 ratio. So 1 mole of NH3 goes on the bottom, so it cancels out. And then what you are trying to get to goes on top, 1 mole of HNO3. So you just multiply this across. 824 grams times 1 divided by 17.04 times 1 divided by 1 gives me 48 point, I don't know, somewhere around 3.5. The unit is moles. Okay, it is moles. Okay, one more equation, still using the same problem or sample problem. This time they want to know how many moles of water are formed. So again, you're going to set it up the same way. Make sure that your chemical equation is balanced. It is in this case. We are given 824 grams of NH3. First step is to figure out the molar mass of NH3 so you can convert it to moles because we're trying to get to 1 mole of NH3. So if I go back to the previous slide, the molar mass of NH3 was 17.04. Okay, now the second conversion is the mole ratio. So I get that from the equation, 1, and we are trying to get to water, also a 1, another 1-to-1 ratio. All right, so I'm in moles of NH3, that goes on the bottom. I'm trying to get to water. I punch it in. Notice that I got the same answer as the previous problem. You might get that. Doesn't mean that you're wrong, okay? So that's kind of the reason why I did this, to show, hey, you're not wrong if this does happen on an assignment. I mean, you probably did it right. So just make sure you double check. And I know we did this right. So that is from going grams to moles and moles to grams. So you do have an assignment. I think we're Zooming tomorrow. Bring your questions, and let me know if you have any problems.